Hi, and welcome to Module 11 in Lecture 1. In this relatively short module, we're going to discuss three things: reliability, bias, and validity. The reason is, as we said in the previous module, we want measurements that are reliable, unbiased, and valid. So let's start with reliability. Reliability is the extent to which reapplication of a measurement produces the identical values for a variable, right? So if I do it over and over and over again, I get the same answer every time. If you can't do this for your dependent and independent variables successfully, your confidence in your results is diminished. So, for instance, if you're trying to code newspaper articles on the president as either having a positive or negative tone, right? The reliability means when you code these articles, you should get the same thing every time you code them. A typical way of testing that is by using multiple coders in any given article. So you give the article to two different people and see if they agree more often than not. The more they agree, the more you think your measurement of this coding is reliable. The more they disagree, the more it seems to rely upon random differences in coders, and the less reliable is your measure. Another example is weighing yourself on a scale, right? A reliable scale would give you the same weight every time that you measured that you were the same weight. So typically what you do there to test a scale is to test and test again a few seconds later, right? If you test 5 times in a row in very short order, you assume they didn't change weight within 25 seconds, so you should get the same answer more or less every time. That's a different way of testing reliability. Reliability is important, and there are a lot of different ways of testing it, of assessing it. We mentioned 2 of these already. So test, retest, you do the same measurement at different points in time, and as long as the underlying character of the measurement doesn't change, so in your weight in this case, it should stay the same every time. So testing, retesting is a way to see if the measurement is reliable when the underlying factor it's measuring doesn't change. The bottom one I'll do next, we said already, integrated reliability. If you have a case you're trying to code, you can take multiple coders for each case and see if they agree. And they should agree a lot of the time, and if they don't, you have a decrease in reliability. Alternative form. You can take 2 different measures of the same concept at 2 different times and see if they agree, right? So if you want to claim that a population is high in partisanship, which you measured by some question asking them about partisanship, you could ask them later about their typical vote choice. And that also should display the same type of behavior as the partisanship question if you reliably have a good measure of the partisanship of the population, because partisanship should lead to sort of constant vote choice associated with your partisan preference. Or you can use split halves. You can split your cases up and use 2 different measures of the same concept at the same time on 2 different parts of the population or the sample you have, and if they agree in the measurements, assuming that the samples aren't too different, then you have more confidence that each measure is getting at what you want to get at. Bias and reliability, is about getting the same answer over and over again, but it says nothing about whether or not when you're not reliable. It doesn't say if it's due to random chance and just not a very constantly useful measure, or actual bias. So it's worth discussing bias separately. Bias here is systematic measurement error. And the idea is your measurement might be reliable, but it's off the mark, right? You're constantly getting high or low, too high or too low measurements for your values of interest. And I should say here, it says it's reliable in the definition here, but it doesn't have to be reliable. You can be biased and unreliable as well, right? You could always be too high with every one, but be all over the place as well. You can still, when you have biased measurements, recover associations between the independent and dependent variables, right? Because remember, you're looking at how changes in the independent variables are related to changes in the dependent variables. So even if everything is a little high, the changes might still be correlated. But you still must be skeptical when you have biased measurements of the size of the mean of things, because it's biased upward or downward, and also the exact relationships you identify via your models, like things like regression, like we'll talk about in a later lecture. Okay, now turning to validity. Definition of validity here is the extent to which your instrument measures the concept of interest. Right? Does what you're measuring map onto your theoretical concept you intended to measure, right? So if I'm asking you, for instance, about how to measure racial attitudes, how would you go about doing that in a valid way? Well, you could just ask people, right? How prejudiced are you, right? But there you're really getting at their willingness to reveal prejudice and not actual prejudice. Now, it might be that's a reliable measure, just bias downward, for instance. Some people won't want to express their true prejudice and won't say anything, whereas other people will feel free to say how prejudiced they are. But if everyone, if that just biases the true value downward, it might be kind of the same as self-reporting turnout, just the opposite direction, and you can still understand stuff. Or maybe it's a not very helpful measure because everyone just hides their prejudice and does so in a way that's correlated with some other thing of interest you have, in which case you would have very bad results if you just use this measure. That depends on the questions you have available and the variables you're using. But in general, the important thing to remember here is you want to use measurements that are valid for your underlying concepts, which means you want to match your theoretical concepts as closely as possible with your measurements and think about problems and threats to validity of your measurements as compared to your concepts. So there are many different ways to sort of get at that. One is called face validity. It's a kind of I know it when I see it kind of thing. So do reasonable people agree with your measure, right? If you ask 20 people about how to measure racial attitudes and they all kind of agree that one measure is bad and one measure is good, you can say your measure has face validity. More frequently, it's not 20 people at random, it's the literature, right? Who has studied this before? What have they thought about? And if people agree that those measures are good, then your measure, if it matches their measure, has face validity, right? Reasonable people who are learned in the area agree upon a good measure. But there are other kinds of validity checks too. One is content validity, right? Does your measure have all the necessary elements? For instance, if you're measuring democracy, you want to make sure your measure has all the elements associated with democracy. Another commonly used validity check is construct validity. The idea is, does your measure produce the same relations with respect to other variables as other related variables do, or as predicted by theory? So that's a little fuzzy, so let me give you an example. Let's say I'm measuring political knowledge via a battery of factual questions about government and politics, right? And I want to see how valid that measure is. Right? One thing I can do is check its face validity by seeing what people in the literature have done before to measure political knowledge. I can also use content validity to get a sense of, did I ask all the questions that a reasonably knowledgeable person should know in politics? Did I omit things selectively? Did I include all the important ones? But a third thing you can do is check to see how that measurement you took correlates with other things other variables it should correlate with, theoretically. So in this case, knowledge should correlate with things like education and income and likelihood of voting, because we know it does from prior research. So you can check to see if your measure of knowledge correlates with education and likelihood of voting and income. And if it does, then we think that your measure of knowledge has construct validity. In general, though, this is the least obvious one, right? Bias and reliability, they're not easy or simple to get in your measurements, but understanding them is more straightforward. Whereas validity requires a very firm and clear conceptual definition of your variables, and then validity is about matching that definition, not about matching others' definitions. So it's a little more fuzzy in that sense. And here's what I'm capturing reliability and validity. To be frank, this is from a different source. To be frank, I would call validity here bias as opposed to validity, but I didn't want to change it because it's from a different source. The idea being, on the leftmost picture over here, right, you have good reliability. You're getting the same result, or very close to the same result every single time, but it's not really capturing your concept, or to bias to over here, whatever you want to call it. And the second one is very unreliable. You're getting things all over the map. But on average, they're capturing your concept, right? The average of all these things is somewhere near the middle. So on average, they're capturing your concept. It's just that it's so unreliable, it's not super useful without taking a lot of data to average it all out. Whereas the third one is the ideal. You're getting the bullseye every single time, good reliability, low bias, or good validity. So this is a sense we're looking for here. And again, all these measurements that you take should, as much as possible, be reliable, unbiased, and valid. In practice, measures often aren't always reliable and not always unbiased. So do the best you can. Validity is really important though, because if it's not valid, the inference itself doesn't mean much. Whereas reliability, you might be able to get away with by averaging. Bias, if you know it exists, you might be able to subtract away from all your data, right? So if I move all 5 of these over here, if I subtract out the bias, I can get back to a good outcome. If I averaged everything, I could get a good outcome. But if I'm just wrong about the measure, if it's just not at all appropriate, right, for the concept, there's not much I can do about it. So make sure that you've thought carefully about the validity of your measurements when you measure things.